Hello everyone. So far we have discussed about different kind of symmetric algorithms, asymmetric algorithm, and the purpose of utilizing symmetric and asymmetric cryptography was to enable encryption so that the data gets encrypted and nobody in the between who is listening in should be able to intercept what exactly the message is being shared. So it allows you to achieve confidentiality in when sender and receiver are sending messages between each other. But it doesn't allow data integrity. And what was data integrity? If you recall, that confidentiality was that if there is a person in between, he should not be able to intercept, even though he listens in. Confidentiality basically mentioned that nobody in between should be able to modify the data. So if Trudy is in between the two, um, when Alice and Bob are sending messages with each other, Trudy should not be able to modify the data and send it back in a different way. So, in order to achieve this data integrity principle, we can use two kinds of algorithm, MAC and cryptographic hash functions. The beauty of using MAC is that besides the integrity, you can also achieve authentication. You can have like because the message the name itself contains authentication word. So in this particular small video recording, I'll cover message authentication code, and then I'll record one more, which would be for cryptographic hash function. As I discussed, I'll not be covering digital signature because of the time constraint, but digital signature helps us to achieve integrity, authenticity, and non-repetition. And I had covered a very small snippet to discuss about digital signature in general. Okay, so if we try to see what exactly is MAC in general, MAC is a message authentication code algorithm. What it does is that it takes the message. So let's suppose you have a message M. You pass it to the MAC algorithm using a key, and both message and MAC gets appended with each other. So let's suppose you are passing a key K to a MAC algorithm that produces an output called M dash. This M dash gets appended with the original message, which is M, that gets passed on the channel, and then in between anybody who is listening in would be able to understand, like, because the message is as is, you're not encrypting the message, you are just calculating the MAC, which is M dash, and which is being transmitted. So in this case, when you are transmitting M and M dash, you will see that on the receiver side, even though the person who is at the in between can listen in and can intercept the message, on the receiver side, if you want to check whether the message was originally sent by you and not modified by anyone, then what you can do is, once again, you will be passing the the message with the MAC algorithm. So both MAC algorithm that you are choosing would be both at the sender and the receiver side, and the key K would also be shared between the two parties. And once again, on the receiver side, the message would be passed on the MAC algorithm to produce the MAC output. And if the MAC output that you are getting is M dash again, then it means that the message was not modified in between, and it is as is message. So in this way, you achieve the data integrity property that nobody is able to modify. Authentication, by saying that this message was not modified in between, and it was originally sent by this guy who has done the MAC algorithm. If there is another person, there would be another MAC algorithm shared between the two, because you do not want the MAC algorithm to be shared between the two parties, which is same for different communication that you are using. So this helps us can provide authentication, but not confidentiality, and also it helps us in achieving the integrity property. But how do we achieve confidentiality then? Because confidentiality is also important because we do not want anybody who in between. So let's suppose Trudy is there or an Oscar is there in between. And if you are sending the transmitted message, Trudy should not be able to change the message and then send it, not listen in, not change. Change is achieved, but not understand what is being transmitted. So this can be achieved, confidentiality can be achieved by two kinds of technique. One is authentication tied to plain text and another one is authentication tied to ciphertext. So what exactly this is, this phenomena is, in the first case, which is authentication tied to plain text, you are, what you do is that you do not provide the encryption on the ciphertext, but you provide it on the plain text. So what does that it means is, so once again, you have message M, it is passed through the MAC algorithm, a key K is applied. So once again, this key K is shared between the two parties, and this will produce an M dash output, which is the MAC output. Both message and M dash, which is the MAC algorithm producing the output, would be appended with each other, and then that would be encrypted using key K dash. Once again, K dash would be shared between the sender and the receiver party. So this, once it gets encrypted, so if Trudy is in between of the party and is in listening in, would not be able to intercept. And once again, this K dash could be either could be a symmetric key algorithm or it could be asymmetric key algorithm. But since it is a single key that is being shared, it is a symmetric key algorithm, which means that both the sender and the receiver would have the same key, which is available to share between the two parties. So on receiving side, once you are receiving this particular message, that message is passed through the decryption algorithm using the key K dash to produce once again M and M dash. Once again, it is a symmetric key algorithm. So K, once you apply the key K dash using the decryption key, so both K dash could be the same kind of key or a different key. It could be private public pair. But in this case, if it's a symmetric key, so same key is shared. So it will produce a message M and M dash because you are decrypting it. So M and M dash would be produced. Once again, this M would be taken and it would be passed through the MAC algorithm using the key K. Once again, it is shared between the two parties. It will produce an output. If M dash is produced, then this M dash would be compared with each other, then it says that yes, nobody was able to modify the data. But in case if it produces M double dash or something else, then we know that this message was originally modified by someone in the between. So this is authentication tied to plain text where you encrypt the message after you have appended both the message and the MAC output M dash. There is another algorithm which is applied, which is called as authentication tied to ciphertext. In this particular case, what you do is before passing it to the MAC algorithm, you encrypt the data. So here in this case, what happens is once again, message M is is encrypted using the key K dash. The output would be some encrypted data. That encrypted data would be passed through the MAC algorithm using the key K. That would be, so this would produce some ciphertext, right? Because you are taking a message, applying a key K dash, and then you are encrypting it. It will produce a ciphertext. That ciphertext would be used, and the MAC output, which was M dash, that would be appended with each other and that would be shared. So you are here applying the encryption algorithm before passing it to the MAC algorithm. And then using that ciphertext, rather than sending the message, you are sending the ciphertext passed to this encryption algorithm and the MAC output, which is M dash. On receiving this, once again, what it does, it applies the decryption algorithm using the key K dash, and then it will produce an output which is M message, because this K, you are decrypting it, it should be producing the original output. So that message you are able to receive, but if you want to apply the MAC algorithm, you would be applying the MAC algorithm on the ciphertext, because here you are passing the ciphertext to the MAC algorithm, not the message to the algorithm. In the previous case, it was the message that was passed because you were applying the encryption after you have appended both message and the MAC. But here in this case, ciphertext would only be passed to the MAC algorithm using the key K, and then that would produce once again some output, which is M dash, that M dash and M dash, which is the original one, which was sent from the sender, would be compared with each other. And if this is same, then it means that the message was not modified in between and the message was not changed. It is also encrypted. So you achieve both confidentiality and integrity property. But originally in MAC algorithm, you just achieve integrity property. So these are two ways that you can achieve it. There are limitations of MAC algorithm. So one basic limitation, as you can see, is that how do we share the secret key, which is being shared between the two parties, right? Because both when you are achieving just the integrity property, what you are doing is you are passing it in a MAC algorithm using a key K, which should be shared between the two parties. And if you are applying the encryption algorithm, then you also have to pass on K dash. Once again, if you are using symmetric, then it has to be established. If it is an asymmetric, then you can use public and private keys. But here in this case, both key K and K dash has to be shared between the two parties. So that is one of the problem. And the second one is the inability to provide non-repetition. So if you remember, non-repetition is a property, non-repetition is a assurance that the message originator cannot deny that this message was sent by me or someone else. So message authenticator should be able to testify that, yes, I was the one who was sending these messages. So MAC technique does not provide a non-repetition service if the sender and receiver get involved in a dispute over a message. Then MAC cannot provide a proof that a message was indeed sent by that sender. So that is another issue with the with MAC algorithm. Though there is no third party that can compute the MAC, but still sender could deny having sent the message and claim that the receiver forged it, as it is impossible to determine which of the two parties computed the MAC algorithm. So you cannot achieve non-repetition. So MAC is one of the algorithm that is utilized to achieve data integrity. And these are the issues. Another important algorithm that we can use is hash functions, and hash functions can also achieve a kind of integrity, data integrity property, but here we do not use a key. We do not require that both the sender and the receiver should share the messages and other thing, but it is more of a data structure kind of thing. And partly you had also understood the concept of hash function when we were covering distributed ledger technique, which was the Tangle CV, where we were storing the data in a ledger, and then it was passed through a hash to produce some output, which was alphanumeric numbers. So hash is another kind of function which is utilized, and I'll create another small recording for you to understand what exactly is hash function. Thank you, everyone.